So basically a front's a boundary between two air masses. And we have cold, warm, stationary, and occluded. And what's important here is that each front has its own individual characteristics. Please notice the symbols. They're actually in page 13 in your reference table. The symbol itself is going to tell you the direction of motion. Cold, occluded, warm front, those are no problem because they're actually moving in some sort of direction. Stationary front, they don't move because you get air masses colliding with each other in opposite directions. So let's start out with the cold front. This is where a cold air mass is trying to overtake a warm air mass. What happens here is that you tend to get very heavy precipitation, tornadoes, you tend to get thunderstorms, very simply because you get a very quick change in the atmosphere. Cold fronts travel very quickly, so they force that warm air up so rapidly, condensation is so violent, you get that nasty precipitation right at the frontal boundary. Once that air mass travels through, though, you get higher pressure, cooler temperatures, and much, much drier air. So you can see that here's your highlighted region for the front. Before the front, you have the warm air. Behind the front, you have the cold air. The boundary, you notice it's a very steep boundary, which represents you have a very, very quick change in atmospheric conditions. The rapid condensation, the rapid lifting of the warm air, dramatic precipitation right at the frontal boundary. Warm fronts are the exact opposite. Here's where a warm air mass is trying to overtake a cold air mass. You tend to get gradual precipitation. Usually occurs over a couple days. So if you tend on getting a warm front on Wednesday, you're going to get precipitation probably Monday night into Tuesday. Very gradual precipitation because the warm air lifting is not as violent. Once that warm air mass passes through, what's going to happen is you're going to get lower pressure, a little bit warmer temperatures, and a little bit moister air. So you'll see before the front you have the cold air, behind the front you have the warm air. Here's your frontal boundary there. You'd notice that the precipitation occurs before the frontal boundary actually comes through. Very slow, gradual precipitation. So there's your cold front on the left. You'll see the cold air is going to be coming down from Canada. So you see the temperatures in the 20s, the 30s, the 40s. You see the warm air mass is traveling in a northwest direction. And what's going to happen here is your warm air in the 60s and 50s are going to be traveling in a northwest direction. The reason why they're traveling like that, because low pressure goes in a counterclockwise rotation. Occluded fronts, or your mid-latitude cyclones, this is where your cold front and warm front actually meet up with each other and they merge together, they zip together. You are going to get major, major precipitation with these types of storms. And what's going to happen here is when you look at a satellite image, you're going to notice a mid-latitude cyclone because of the classic Kama cloud. And you'll notice in this picture from 1998, the classic Kama cloud extends from Minnesota all the way down into the Gulf of Mexico. Now, on the left-hand side, that is your mid-latitude cyclone. On the right-hand side, that's your occluded front. The mid-latitude cyclone hasn't zipped together yet. The occluded front, it has zipped together. That's why you have the purple head to that specific front, because you see the merging of the warm front and the cold front. Now you see here, the cold air is on the left. The cool air is on the right. The warm air is in the middle. The cold air catches up to the cool air, forcing that warm air up very rapidly, and you get a significant amount of precipitation with that rapid rising of warm air. So again, you can see on the left-hand side, that's a mid-latitude cyclone about to zip together into an occluded front. There's the temperatures between the cold front and the warm fronts. So you see the big major warm sector there. And in this picture, you can actually see the occlusion that is actually taking place. The last type of front is what we call stationary front. And this is where warm front and cold front is going to collide together. They kind of battle for supremacy, so they kind of stall out and they don't move until one of the fronts actually weakens out. And you tend to get a little precipitation here because warm air does rise up a little bit, but they are a little bit battling here for supremacy of the area. So you'll see that the picture on the left shows you the stationary front symbol. On the right-hand side shows you what it might look like from the side as well. And again, here's a weather map that just gives you an idea in terms of where a stationary front might be located and the different characteristics with it.